Okay, now that we've defined artificial intelligence, let's look at its two main capability branches, narrow AI and general AI. Narrow AI, also called weak AI, is what dominates today's landscape. These systems are designed to do one specific job extremely well, like recommending songs, identifying objects in images, or analyzing medical scans, but they don't understand beyond their programmed task. For example, in my own healthcare work, I built models that detected anomalies in MRI images. They performed that task with high accuracy, but they didn't comprehend anything outside that domain, a classic case of narrow AI. Then we have general AI or AGI, the idea of machines with human-level intelligence that can learn, reason, and adapt across many tasks. This is still theoretical, but it's what science fiction often envisions, like Data from Star Trek, an android who can reason, create, and collaborate like a human. If AGI ever becomes reality, it could transform entire industries from medicine to transportation, but we're not there yet. Now, when we talk about generative AI, it's still within the realm of narrow AI, though it's beginning to show signs of more flexible cross-domain learning. Additionally, AI can also be grouped by how it works, the technical approaches behind different systems. We started with symbolic AI or rule-based logic, those if this then that systems from the early days of computing. Think of medical expert systems that suggested diagnoses based on symptom checklists. They were smart but rigid. Then came machine learning, which learns patterns directly from data instead of hard-coded rules. In banking, for example, my team built ML models to detect credit risk. These models improved automatically as they processed more data, like how spam filters get better at catching unwanted emails over time. Next is deep learning, inspired by how the human brain processes information. Using neural networks, deep learning enabled breakthroughs like AlexNet, which revolutionized image recognition in 2012, and AlphaGo, which beat the world champion at Go in 2016. The invention of transformers in 2017 then opened the door to today's large language models, the foundation of generative AI. We also have reinforcement learning, where systems learn by trial and error, receiving rewards for good actions and penalties for bad ones. I've used similar techniques in quantitative finance, where models simulate thousands of strategies until they find the most effective one. Okay, finally, generative AI represents the newest frontier. Instead of just classifying or predicting, it creates, generating new text, images, or code. In one of my projects for government modernization, I used retrieval augmented generation, RAG, to make complex legal information more accessible and accurate for policymakers.